Welcome back to our ongoing discussion of SQL. This is video number 1, which introduces the select statement. It's based upon chapter number 1 in the free SQL book, which can be found at the designated website. There was a preceding video to this video, which was based on chapter 0 in the book, and rookies are encouraged to watch this video 0 on chapter 0 before watching the current video we're watching now. This video will introduce the select statement, and we're going to take a look at 5 sample queries. And after that, we'll say a little bit about the difference between standard SQL, which is defined by a SQL Standards Committee, and non-standard SQL, meaning something like the SQL Server version of SQL or the Oracle version of SQL. Then we say a little bit more about comparing character strings. There's a few subtle points on that we want to address after we present the sample queries. And then we want to help you get into the hands-on SQL if you have not already done so. There we will discuss the free SQL script, which will create the sample tables used in this book. Alrighty, here we go with the first sample query, display the entire table. What we really want is to display all columns in all rows. If we say select star, that's an abbreviation for all columns in the table, no matter how many columns are in the table. Then we have the name of the table, the preserved table, which was described in the preceding video. And then we bring to your attention that this select statement does not have a where clause. The absence of the where clause means show me all rows. There are 14 rows here, fortunately not 14 million, and you're looking at them right now. We want to bring to your attention the logic says no where clause implies retrieve all the rows. So we don't do things like this with a 14 million row table. Next observation, which I think is important, is that if you look at this table closely, you will see that it's not sorted in any particular row sequence. And thereby we want to bring something to your attention. Tables in a relational database do not have any predefined row sequence. When we looked at the create table statement in the preceding video, there was no mention about row sequence. If you want to see the results sorted by a particular column, then you want to use the order by clause, which will be presented in the next video corresponding to chapter 2. Having said that, some of you, when you execute this simple select statement, might see an incidental row sequence. What do I mean by that? The rows appear in some sorted sequence, even though you did not specify an order by clause. We address that circumstance in the following video. I want to make some observations about this simple select statement. First of all, we have reserved words or keywords. Select, from, and where are reserved words in the SQL language. You can look those words up in your reference manual. Now, there is a termination character at the end of a select statement. It's the semicolon. Many times we don't need it. But if you start to string together multiple SQL statements, then you'll want to use that semicolon as a separator. That's what it really is. But you can think of it as a symbol to terminate the end of a select statement if you want to. Now, sometimes you can write your select statement on one line. In this book, my examples will show the select clause and the from clause and the where clause. Each clause will be on a separate line. And finally, one more observation which will be pertinent later on in this video. I bring to your attention that the pname column and the state column, the only two character string columns in this table, happen to have their values stored in uppercase letters. Finally, this particular language, SQL, does not directly support formatting. You won't see commas and dollar signs inside numeric values, even if they do represent money. Okay? Some front-end tools, dependent upon the front-end tool you're using, can provide the formatting that you might desire. All right, let's take a look at the second sample query. Display all information about any nature preserve with an admission fee of $3. Display all columns in these rows. Well, select star gives me all the columns from the preserve table where fee is equal to $3. Even though we said $3 in the query objective, you will not code the dollar sign in the where clause. And what does that do? That retrieves just those rows where the fee value is 0. Now, you can compare on greater than, less than, greater than or equal to, less than or equal to, and not equals. We'll see more of that later on with sample queries. There's no punctuation, as we just said, but you will see a minus sign in the event that the numeric value is indeed negative. Now, in the spirit of knowing your data, you want to know that the fee column is a numeric column. That means you're doing a mathematical compare. Hence, if you said fee is equal to 3 without specifying the 0.00, or just 3.0 or 3.000, they are all valid and they would all get the desired result. Obviously, you might want to specify 3.00 for the sake of being tidy. Now, here's a buzzword. The buzzword is restrict. I will use it occasionally throughout this series of videos, and it simply means I want to pull out a bunch of rows. I want to get a subset of rows, but I want to retrieve all the columns from those rows. So the result that you're looking at here is really a horizontal subset of rows. Some rows, but all columns. All right, let's do another compare. This time the compare is on a character string. The query objective, display all information about any nature preserve that's located in Arizona, which really means display the rows where the state value is equal to AZ. So select star gives us all columns again from the preserve table. We say where the state column is equal to AZ. We bring to your attention that AZ are in uppercase because the data is stored in uppercase, and it's enclosed by apostrophes, not quotes. Forgive me when I say quotes. I'll be getting sloppy if I do that. When you have a character string, it's enclosed in apostrophes. The result shows the 4 rows corresponding to the state of Arizona. So we get all columns, but just those 4 rows. So this is another restriction. We note that the state is a CHAR, a fixed length data type. More on that later on. And we note that unlike a numeric compare, this is a character by character comparison, not based upon some mathematical comparison, where you can just look at the value without regarding to the format. The next character, the next sample query also compares on characters. Display all information about the Ramsey Canyon Nature Preserve. Well, now we're looking for preserves based upon their name, so we got to know, oh yes, the names of preserves are stored in the P-name column, so we're doing a search on the P-name column. We want to find the Ramsey Canyon Preserve. Again, that name is enclosed in apostrophes, and we get a 1-row result. This time we bring to your attention that the P-name column is a VARCHAR data type, where the previous example for the state column was a CHAR data type. CHAR versus VARCHAR, I have not told you the difference yet. Okay, that's important. But most of the time, there'll be no difference for basic comparisons as illustrated here. And we will not worry about that till later on. Sample query 1.4. Now we want all the rows, but we only want to identify a subset of columns. We only want to see the P names and the acres and the state values for all rows, and we want to see the name, the acres, and the state value in that left to right sequence. So how do we do it? Well, just put the names of the columns in there and separate the names of the columns by a comma. All right. I bring to your attention that we've got a vertical subset here. What we have are all rows, but just some of the columns. And sometimes we use the buzzword project for that. Project out just some columns from the table, which means we want all the rows, but just some of the columns. Finally, when we get to sample query 1.5, we emphasize that there's nothing new here. If you understand the preceding 4 sample queries, there's nothing new here. We want to get data from the preserved table. It appears in a from clause. We only want some of the columns. Which columns? The name and the acres. We don't want all of the rows. We just want the Arizona rows. That's specified in the where clause. So there's nothing new here. Conceptually, we've done a restrict. We've pulled out some rows, and then we did a project. We pulled out some columns. Most of the textbooks will not use the buzzword restrict and project, but I will do so periodically throughout these videos, and they're not hard to understand. And you might have heard me use the word subset a few times, and I'll explain that verbiage later on also. Well, let me say a word about it now. There is a mathematical theory behind the select statement, behind the SQL language, all right? You don't need to know it. But some of the buzzwords from the theory sneak through sometimes when I speak to the SQL language. Now, I bring to your attention that there's 3 criteria that can be used when you look at a select statement. The most important criteria is that it produces the correct result. You might worry about efficiency. If you had a 14 million row table, you might say, once I hit the enter button and tell the system to execute this select statement, well, I have to wait a long time. And that can be an issue, but we're not looking at that particular issue now. We don't want to do the wrong things fast. Once we know how to do it right, then we can talk about efficiency, and that will be described in the textbook, but not in the videos. Finally, when you write a more complex select statement, it might not be too friendly, and you might say, is there a way I can make this more appealing so it will be easier to be modified for somebody who comes after me and has to change this select statement for whatever reasons? We do not focus very much on friendliness in this set of videos. Occasionally, I make a comment on it. So what we'll do, having emphasized the importance of logical correctness when coding your SQL, we now turn our attention to what we mean when we talk about standard SQL. We want to address the issue of different database systems, such as Oracle versus DB2 versus SQL Server versus MySQL. We note that the preceding select statements for the preceding sample queries worked as is on all of these systems. But there are some differences, all right? And we'll comment on that in a moment. Standard SQL is a real standard defined by the ANSI, the ANSI Standards Committee. This committee has representatives from the Oracle Corporation, the IBM Corporation, the Microsoft Corporation, etc. Therefore, their products conform to that standard quite a bit. But here I put standard in quotes because of the variations which will pop up during this course. Despite those variations, there is a significant overlap in the SQL, which means I can present a video or write a book on SQL and only occasionally have to point out those differences, as we will do as we proceed through these videos. So when I say standard, I'll talk about the unofficial, ill-defined core SQL, vanilla SQL, that works on all systems, despite those minor variations I will address. In addition to different systems, the same system might have different behavior because of the defaults. For example, let's consider coding a where clause that says where the state column in the preserved table is equal to AZ, and we code a lowercase az, even though we know, based on our previous observations, that the values stored in the state column are all uppercase. The question is, will this work? Will it select all the desired rows? Well, it depends upon the system, and on the same system, it could depend upon a default. So, this book will take a look at core vanilla SQL relative to the topics which are listed in the table of contents, which is, again, core SQL. We will comment on SQL differences relative to the 4 database systems I have mentioned here. Now, moving on to section C. I want to talk more about character string comparison. Now, the examples we saw in the preceding sample query were quite straightforward. They work all the time on all systems. But here we want to address some concepts. There'll be no new sample queries, no new SQL code, and I want to raise awareness about potential problems that are easy to fix once you're aware of the problem, okay? And it's not going to be difficult to be aware of these problems. So we're going to start off by assuming the preserved table is clean. In that sense, I mean that there are no leading or trailing blanks, no multiple blanks between two words, like Ramsey Canyon. We have Ramsey blank Canyon, not Ramsey blank 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 Canyon. And again, there's no lowercase data in there. And in that context, I want to address some issues. First and foremost is about the difference between CHAR and VARCHAR. Some systems, some applications simply define everything as VARCHAR to avoid the problems that we might bump into along the way. We want to recognize messy data. I'll show you how to find it later on. You might want to know that before the first character in Dancing Prairie, there are multiple blanks. And before the last character, there are trailing blanks. That's kind of messy. We also want to avoid messy code. This you can do because you've got control over it. What happens if you code where state equals AZ? A is uppercase and Z is lowercase. Or you get uppercase for A and Z, but then you have trailing blanks after it. All of this raises questions, and we will talk about the potential problems with these, but again, we will note that we can solve some of those problems, and that will be done by looking at topics, previewing some topics in chapters 6 through 10. So, can we fix these? Yes, once we're aware of them. Let's take a look at CHAR versus VARCHAR. Now, this is an internal structure. What does the data look like on the outside? We'll assume we have a table, not defined here, with a column that contains the name of the states, the full name. So there they are, Montana, Massachusetts, New Mexico, and Arizona. Now, by eyeballing this, you got to believe me on this one, you cannot eyeball this column and deduce the fact that it is either fixed length or variable length. Let's come down and take a look at the internal structure for these two data types. If you defined it to be 14 characters long of the CHAR data type, then every value must be 14 characters long. And if they are not inserted with the data, which we usually don't do, then the system automatically pads the value with trailing blanks for you. Montana takes up 7 characters. The system automatically puts in 7 blanks, represented by the red B's here. Okay, Massachusetts would be stored with 1 trailing blank, etc. However, if we have a VARCHAR data type of the same length, here the length 14 means the maximum size. So we would have Montana without any trailing blanks, and the system would store somewhere the length of the string, which is 7 for the 7 characters of Montana, 13 for the 13 letters in Massachusetts, 10 for the 10 letters in New Mexico, including the blank in the middle, which is not a trailing blank, and 7 more for Arizona. All right. Now, you don't eyeball the inside. You just have to be aware of this. Okay, let's take a look at the next issue. Clean data versus messy data. Let me go back to the preceding page. For tutorial purposes, I emphasize that the state name is a fixed state name with an F in front of it and a variable state name with a V in front of it. Now when I talk about F state name, I'm talking about a column which is stored as a CHAR data type. And when I say V state name, I'm talking about a column that's stored at a VARCHAR data type. What do we mean by clean data? To be precise, we say it conforms to design specifications, whatever they are. An example is all the letter values in the 2 character string columns are in uppercase. No leading blanks, only 1 blank between words, like Ramsey Canyon, and only the fixed length CHAR data type is allowed to have trailing blanks. It is usually the case that a VARCHAR field does not have any trailing blanks. But it can happen, we will address it. Messy data does not conform to design specifications. Here's New Mexico, but some of the letters are lowercase. Here's New Mexico with a leading blank, multiple blanks in front of N. Here's New Mexico with multiple blanks after the word new. And here's New Mexico with multiple blanks after the letter 0 in the variable length character string. To have trailing blanks in fixed length character string is okay. By the way, you kind of hope you always have clean data, but sometimes you will encounter messy data, and we want to help you find it and fix it. But first of all, you need to be aware of it. Let's take a kind of simple issue, case sensitivity. We know that the state and the P name columns are in uppercase, and therefore we coded an uppercase A and an uppercase Z, and that works, and it works all the time. Question, what if somebody coded lowercase a, Z, or partial A is uppercase, Z is lowercase, or vice versa? The question would be, would this work on your system? Well, here's the answer. It works on some systems, but it would fail on other systems. Now, I wish I could tell you that it will always work on Oracle and DB2. Excuse me. It would fail on Oracle and DB2. And I wish I could tell you that SQL Server and MySQL, it will always work. Let's just get a definition first. If the system responds with a no-hit when you code one of these three where clauses, unlike the one we saw in the sample query, we say that your system is case sensitive. Okay? However, some systems would return the desired Arizona rows, in which case your system is case insensitive, which means you probably could be a little sloppy in your coding of the where clause, but we don't want to encourage that. Now, as I said a moment ago, DB2 and Oracle, they default to case sensitivity. What that means is if you were to start from scratch and load your own PC version of DB2 or Oracle, you being the database administrator have installed the system and it's day one. And in that circumstance, Oracle and DB2 would be case sensitive. However, if you did the same thing with SQL Server and MySQL, they would default to case insensitive. Okay, you can remember that, but here's the big problem. Even with the same systems, the defaults can be changed. Uh-oh. So let's talk about defaults. Now, I'm going to give you some bad news, but let's start here. There's some good news to begin with. Some good news. If you don't like a default, most likely you can change it. All right? And you'll change it for the one SQL statement you're about to code. How you do that, we'll get to later on, again, Chapter 6 and Chapter 10. But we're reminding you that your system on day one, when it's installed, has defaults. Now, for reasons I'm not going to describe here, the DBA might want to change the default. It defaults to case sensitive, the DBA wants to make it case insensitive, or vice versa. And then to muddy it further, sometimes the front-end tool might automatically change the default for you. Of course, you could hunt around and then change the default on that front-end tool. So the bottom line is things can be changed along the way. And if you come in the middle, the system's been running for 2 years and you've just been hired as a new application developer, then what? Well, I want you to be aware that there are relevant defaults and they're pretty easy to learn. For example, where state equals quote AZ, where AZ is lowercase. If you get a hit, it means it's case insensitive. If you get a no hit, it's case sensitive. You can find out pretty easy with a little experimentation whether your system or your database in particular is case sensitive or insensitive. Now, when you write your individual select statement, you can override that behavior. All right? And way up in Chapter 10, Video 10, there are some functions. I know I haven't talked about functions. I think many of you know what a built-in function is. Simply say, there's a way to fix this. The upper function will take any string, and if a character in there is in lowercase, it converts it to uppercase. And lower likewise, if any character in there is in uppercase, it turns it to lowercase. So what we want you to do is be aware of case sensitivity, and it's pretty easy to find out, and it's pretty easy to fix. Now let's take a look at some other messiness. Leading and trailing blanks is pretty much the same, between CHAR and VARCHAR here. Here's an example. Blanks before the first character in a string, or multiple blanks after the first word in a string. Now, the leading blanks are easy to resolve. There's a trim function and an L-trim function to be described in Chapter 10, which trims off the leading blanks. All right, that makes things simple. We'll also show you that there's a little more work to be done to take multiple blanks and turn it into a single blank. That's for the future also. Now, when we get to trailing blanks, we've got two circumstances. The CHAR columns, where trailing blanks are normal, quite frequent, and then we see the VARCHAR columns, where in normal circumstances there are not any trailing blanks. So we'll assume the data is clean. In the fixed length column, the F state name is the CHAR data type. If you write clean code where we want to find the Montana row, it works on all systems. That's all you need to know. Oh, wait a minute. What about the trailing blanks up here? What about these guys? Here's the answer. The systems have their own way to work around that. Okay? Not a problem for the fixed length character strings. Now, I'm not saying what method the systems use because different systems use different methods. Comment on that in the future also. So the bottom line is, don't worry about this feature of trailing blanks with CHAR. Now, can you code some sloppy code, as I show here, Montana with one trailing blank, or many trailing blanks? Maybe if it's Montana, it's the Montana letters followed by 7 blanks, or many more blanks follow Montana such that it even exceeds the size of the length of the column. So the question is, will this work? Will it return the desired rows? Well, again, it depends upon your system and its current defaults, because defaults can be changed. Let me refine this a little bit. It depends upon the version of your system, because sometimes when a new version, let's say of MySQL comes out, the default changes, and that can be kind of messy too. So the bottom line is, what do you want to do? Well, you can experiment with representative data. Now, in my simple preserve table, you got 14 rows. You can eyeball it. But if it's got 14,000 rows, then you're going to have to go out and pull out some rows to eyeball that. However, Chapter 6 will show you a simple method to discover something like a leading blank or a trailing blank. And Chapter 10 will say, after you've discovered this problem, I can help you work your way around it. So what do you want to do? The conclusion for all of this is, sure, eyeball your data if it's convenient. But if it's a large table and the documentation is not very clear, do a little experimentation, all right? And then once you get a feel for what's going on with experimentation, read your reference manual. And by that I mean read the reference manual for the current version of the product that you are using. Now, when we get over to VARCHAR values, as I said before, there are no trailing blanks because the system stores the length of the value. Now here again, as we did when we were looking at the pname column in the preserve table, we say where the variable, the column with the variable VARCHAR data type is equal to Montana. That works all systems. Now here we go again. We ask the same 3 questions. Will you get the desired rows? Once again, It depends upon your system, the version of the system, and the current defaults for that system. All right? Therefore, experiment. And you might find that you're going to get different results with the VARCHAR comparison versus the CHAR comparison. And as I said earlier, for that reason, some systems say, we're going to forget about this CHAR data type and just do everything as a VARCHAR data type. Okay, so how you want to process this messy data? Well, first of all, try to find it. Find the messy data. Go looking for a character string column with a leading blank. And by the way, that's easy to do, and Chapter 6 is going to show you how to do it. Of course, if you find this messy data, maybe you notify the DBA and say, I found some messy data, and I found a lot of messy data in quite a few rows. The DBA says, yeah, I know about it. I'll fix it someday. Right now, I want you to work your way around this messy data. Maybe change to lowercase data to uppercase data for the purpose of your query only. And then you work your way around the messy data and return the desired result. That's pretty easy. That's going to be Chapter 10. Alternatively, the DBA could say to you, you know what, you being the application developer in this circumstance, we want you to clean up that messy data and rewrite it such that future users don't have to deal with it. So you're going to execute update statements to identify the messy data and change it and rewrite it back to the database. You have to learn the update statement to do that, and that's up in Chapter 15. Now, in all my examples, in this video and the preceding video, it was easy to eyeball messy data. So you didn't have to go hunting for it as you would with the techniques we'll show you in Chapter 6. Simply put, eyeballing fails with large tables, and also especially what happens when the code looks like column 1 is compared to column 2. Whereas before you were hard coding a character string in the where clause, as we did with the sample queries. In the future, you will be coding clauses like this. You will be comparing a column to another column, and usually one column is in one table and the other column is in a second table because you're joining the data from two tables together and you're matching on certain columns in order to do that join. If you've never heard the word join, forget about it. Don't worry about it. All I'm doing is saying that your data problem becomes more of a challenge. So the conclusion is know your data. Chapter 6 and 10 will help. And obviously, if you haven't concluded this already, don't write messy code. Now we turn to the last section in this video, hands-on SQL. We remind you that a lecture on centrifugal force does not help you ride a bicycle. Likewise, lectures on SQL that you're getting right now certainly help, but nothing beats some hands-on experience with the language. In order to do so, you have to create the sample tables, which we use in the sample queries and the exercises in this book. There's an appendix, Appendix 1, at the end of this book, called Book Appendix 1, which guides you through the process of creating the sample tables. However, on the following page, I'm going to start you in that direction, and most likely those of you who have some experience will not need to read that appendix. Now, some of you do not have access to a relational database or the front-end tool that goes along with it. You might be a rookie. You're not attending a course somewhere which has a database system. You don't have a job yet. And therefore, you're going to have to create and install a relational database management system and front-end tool on your personal computer. Book Appendix 2 will help you in that direction. Okay, let's move ahead and talk about a SQL script. A SQL script is very simple. It's just a collection of multiple SQL statements, and each SQL statement is separated by a semicolon, and they are executed as a single unit. So in our previous sample queries, we said select star from preserve where state is equal to AZ, uppercase, and then hit the execute button. Then if we wanted to, we followed it with another statement. If you want to, you can bundle together multiple SQL statements as long as you remember to take and package them together with semicolons separating each statement. Now, the scripts that we're going to look at shortly don't have select statements. They have statements like a drop table statement. Let's for the moment assume that you had previously created last week a table called stuff. You played around with it, maybe you made some changes, and then you didn't undo those changes and you would like to start all over again. Well, if you say drop table stuff, you drop the preceding version of that table. Notice the semicolon here again separates the statement. Then you execute the create table statement, maybe the exact same statement you executed last week. Maybe you make some minor changes. And then you insert into that table values, and if you were doing the preserve table, there would be 14 insert statements. Then you might say commit that change. Commit, I haven't said a word about this yet. We'll say more about it way towards the end of the book. But for now, we're simply saying the commit keyword simply says take the changes that you've made and make them permanent, whatever that means. All right, let's look at the script for creating the free SQL tables. Now, if you go to the website, you'll find that there are two scripts. A big script with a lot of create statements, a lot of insert statements to create all the tables that are used in a book. Then you'll find a much smaller script that only creates two tables. And the name of that script is the Chapter 1-5 script. We name it because there are two tables which are the only tables which are referenced in chapters 1 through 5. You've already seen a preserve table, and there's an employee table which is referenced inside the exercises. We encourage you to do a few of them. All right. That commit statement I just mentioned, if you are a SQL Server user, you can take and do two things. Simply remove it, or alternatively, put two dashes in front of it. Two dashes followed by a space. What does that do? It turns the script, it turns that line of code into a comment, and therefore the system ignores it. The comments are for you, the human reader, and if you want to put that in, like I've done with these 3 lines here, then you use dash dash space in front of it. Okay. Because this script is going to create two tables, preserve and employee, we're going to drop the preceding version of those tables. All right. Then we execute the create table statement for preserve, which was presented in chapter 0 of the book was also described in a preceding video. So there they are, the same columns, P&L, P-name, state, acres, fee, same data types, etc. Then we have 14 insert statements, one for each row in the preserve table. Again, forget about details. You're just going to run this script. You don't need to understand all the commas and everything. But it's pretty straightforward if you read it. So there's 1, 2, 3 preserve statements, insert statements. And then, if you look at the actual script itself, you'll find 11 more insert statements. Then there is a commit statement, which says make the changes permanent. Again, SQL Server users should remove this statement. Then there's similar code for creating the employee table and inserting some rows in that table. And you can read about the layout of that table for the exercises, the summary exercises, at the end of chapter 1. Now, I want to make one more statement here. On some systems, such as MySQL, you could have a minor problem here. Say you say drop preserved, but you never created a previous version of the preserved statement. This is day 1, first time you're executing the script. On some systems, MySQL using the Workbench front-end tool, if you say drop table and give it a name that the table does not exist, the system goes, error, stop, I'm not going to go any further. So you want to get by this particular problem. So if you're using MySQL, what you do is make one change to the script we just looked at. You will put in the phrase drop table if exists preserve. So if it exists, it's dropped. If it doesn't exist, the statement doesn't cause an error. It moves on down to the next statement. So you want to do that with MySQL. It also works with SQL Server, but it wasn't necessary. So I'll be putting a separate script for MySQL out on the website. Okay, with the exception of the last page, which merely connects you to the next video of this current video, we're done. Note, pay attention. When all is said and done, pay attention to the first 5 sample queries, the commentary on that, and the rest is conceptual. The discussion of standard SQL, the discussion of messy data and working our ways around that, and then this brief discussion of executing scripts to create the tables you need for the sample database. Again, I thank you for your attention. The next video will discuss the order by clause, which can return a result table in a desired row sequence. Thank you again.